So lesson B is perimeter, area, volume, surface area, and sectors of circles. This is basically a review of a whole bunch of geometry formulas today. All right. So I'm going to quickly give you the formulas so that you have them in your notes. You might want to keep them open when you start the homework set today because there's a lot of geometry today. And then we'll run through kind of the new stuff, a couple examples of the new ones. All right. So triangle. How many of you guys know the formula for every triangle? Silence. Anyone? Anyone? Yes. Thank you very much. Base times height divided by 2. All right. Put these in your notes even if you already know. Okay. Just a reminder that an isosceles triangle means 2 or more sides that are equal. Okay. 2 or more. An equilateral triangle is 3 sides that are equal. You guys don't have to write that down, but if you want to, that's fine. And then some of the angles is really important. So the interior angles of a triangle always add to what? Pablo. Very good. 180 degrees. Okay. That's important. Okay, so review of circles. The formula for circumference of a circle is either 2 pi r or d pi. Okay. And by circumference, that means the distance around the circle. Okay, and then I want to go area. I'm going to do this one next because this is one you're familiar with. What's the formula for area of a circle? Just say it if you know it. It's going to be a long year if we don't know this. Should I just forget this over summer? Someone besides PJ who's like, are you serious? Yes, thank you. Okay, thank you very much. Pi r squared. Okay, that's the area of a circle. Now we've also got arc length and sector. So these are new. These are really important. You might want to star them, highlight them. So arc length. Arc length is where these little smiley faces are. We're talking about the distance of this piece that's on the circle. So if I were to just take this piece of the perimeter and line it up next to a ruler, right, how long is that? That's what I want to know. So instead of taking it off and measuring it against a ruler, we can just use the formula. So the formula is, first of all, we take the entire perimeter, okay, the entire perimeter all the way around, and then what we want is the fraction of the circle, and I put the fraction in front. So the fraction of the circle is theta over 360. Kind of hard to read. 360. So 360 degrees is all the way around. Theta, if you don't know what theta is, it's a O with a tail on it, okay? It's a Greek symbol that we use in math, and it usually stands for an angle measurement. So theta is actually this angle measurement inside the piece of pizza, okay? They give it to you, so you just plug it in, and it'll give you what this distance is here, okay? So that's arc length. Now we've got sector. Sector is the same thing, except for this time we're not talking about the pizza crust. We're talking about the whole area of that piece of pizza. Okay, so what's the area of the piece of pizza? Well, the whole area is pi r squared. And we just want a fraction of it, so theta over 360. Same thing where theta is the angle inside the piece of pizza, also known as the central angle. Okay, let's review everything we know about surface area. Anyone know the formula for lateral surface area? Yeah. Good. Perimeter of the base times the height. Lateral surface area is when you take a can of soup and you take the wrapper off of the can of soup. So it's just the distance around. Okay? And circular, cylinder, and prism are the same. So what is the surface area formula that we use for either one of these? Because they're the same. It's the surface area formula you guys have been using since the 7th grade. Dominic? Very good. exact same thing, except if you're doing a circular cylinder, when you use the formula, what do you plug in for area of the base? What shape is the base? Circle. So you would do pi r squared, right? And for perimeter of the base, it's a circle, so you would do 2 pi r, or d pi, right? Okay. For a prism, let's say it was a triangular prism like this. That's a really bad triangle. But what would be the formula for area of the base if you had a triangular base? Okay, I'll assume you guys are following base times height divided by 2, right? It's a triangle. Okay, and the perimeter, you just add up all sides. That's the formula we use for both of those. All right, circular cone pyramid. These are the same formulas. You probably forgot them. You saw them in Algebra 1 briefly at the very end of the year if you had Saxon math. If you're a 7th grader, maybe not. All right, so for surface area of a cone, it's area of the base plus perimeter of the base times L divided by 2. For surface area of the pyramid, it's the same thing. Okay. Since these are different, for the circular cone, right, you guys know what a cone looks like? Looks like this. For the circular cone, the area of the base would be what formula? PJ. Thank you. Pi r squared. The perimeter of the base would be what formula? 2 pi r. Anybody know what the L stands for? Alex. It is. So they're going to give you the distance of that slant. That's the L. Okay. Now, if we have a pyramid, it could be a square pyramid, a triangular pyramid, okay, but it meets at a point, just like a cone, all right? Area of the base for this one would be what? What would be the formula? Base times height. Perimeter, you'd add them up, and L is the slant height again, okay? So they'd have to give you the distance of one of those, slant height. And then we have sphere. You probably forgot this one, but surface area of a sphere is 4 pi r squared. All right, everything you've ever known about volume review. Circular cylinder. Okay, prism and circular cylinder are the same. What's the formula you've been using since the 7th grade for volume? Amanda? Very good. But, of course, for the circular cylinder, the area of the base would be what? Yeah, Ben. Pi r squared. Exactly. Okay? So, and the prism, it depends on whether this is a triangle, a square, whatever. Okay? We usually just do triangles and squares, but it could be any other shape. Okay, now we have the volume of a cone, a non-circular cone, and a pyramid. These are all really similar, okay? Volume of a cone. Oops, that was not a very good cone. Okay, anybody remember the volume of a cone? It's the exact same except one fraction in front of it. Yeah. Yeah, you could do that. I always do 1/3, but yeah, some people, this is the same formula, so I'll just put it here. You might like putting it over 3. Same thing, okay? So it's 1/3 of the volume of what it would be if it was a whole cylinder, okay? What is a non-circular cone? I've only seen Saxon math do this, but you have some sort of blob, and it meets at a point. Okay, that's a non-circular cone. How do you find the area of that? They're going to tell it to you, okay? Because we don't have a formula for blobs, so they're just going to be like, it's 20, okay? You just plug that in. It's really easy. All right, that's a non-circular cone. And then we have, of course, a pyramid. So you might have a triangle, and then it meets at a point, right? That's a really good pyramid right there. Same formula, area of the base times the height divided by 3. Because it meets at a point, you divide by 3. And again, this one's area of the base would be a triangle, so you'd have to plug in base times height divided by 2. Okay, and a sphere you probably forgot, but this one is 4/3 pi r cubed. So remember, when you're doing volume of a sphere, it's r cubed. When you're doing surface area of a sphere, it's r squared, just like the units would be. Okay? All right, 2 actual problems, and then we'll do whiteboards on these same types of problems. Because this is the new stuff, we're going to do arc length and sector real quick, okay? So find the radius of this circle, or the radius of the circle is 10 centimeters. Find the arc length of a 45-degree arc. So draw the picture for me, okay? That does help if you draw that in your notes. And go ahead and label, it tells us the radius is 10, so both of these distances are 10. I usually just label one of them. And then it gives us the angle inside. This is the central angle right here. If I want to find the arc length, again, it's the distance from here to here. So how long is my pizza crust? So the formula for arc length is theta over 360 times 2 pi r. You could also use theta over 360 times d pi. Okay, same thing. Whatever you like to use for perimeter, whether it's 2 pi r or d pi. Okay. What are we going to plug in for theta? Yeah, what'd you say? Yeah, 45 degrees. Good, over 360. So this is always theta, that central angle. All right. Times 2 times pi times, what do we plug in for r? 10. Good. Now, in Algebra 2, you have to do 2 answers, one with pi and one where you times it by pi in your calculator. Never use 3.14 because we're just going to use the pi button. So if you don't have a calculator, grab one off the desk. If you do have a calculator, grab it out of wherever you have one. Hold on. Let me record this slowly now. That's sad.